So a function by increasing, I mean increasing. So a function is increasing when it goes up, and when it goes up, you can see that the tangent line is gonna slant it up, and when the tangent line slanted up, that means it has a positive slope. But what does positive slope have to do with anything? When a function has positive slope, that means the derivative is gonna be positive. So in all of this, that means if my function is increasing, that's actually the same as saying that the slope is positive. So that's the same as saying that the derivative is positive. And that comes out to be the first line of my thing here. So basically what I mean here is that whenever my function is increasing, the derivative is going to always be positive. And the opposite holds as well. If my function is going down, if my function is decreasing, then if my function is decreasing, then that means it's gonna go down. Then that means it has a negative slope. And that means my derivative is gonna be negative. So that goes my second item. When a function is decreasing, then the derivative is going to be negative. So that means, essentially, if you want to know whether my function is increasing or decreasing, you actually don't really have to do the graph. What you can do is you can find the derivative and see if the derivative is positive or negative. So we will see the example in a moment. But let me go with another item that I have. When my function is concave up, the derivative is going to be increasing. So let me talk about this one next. What does it mean for a function to concave up? When a function concave up, it looks like a U shape. And when it looks like a U shape, if you were to draw the tangent line on, if you were to draw the derivative on this graph, you can see that the derivative of this graph, it starts off being a negative slope. But as my x increases, the graph has a less negative. And then my graph suddenly has a positive slope, and my graph has a higher positive slope. So whenever my graph concave up, the tangent line here, the slope of the tangent line is going to increase as x increases. So if my graph is concave up, let me just say concave up, that will imply that my derivative is going to be increasing. So that's the third point in my table there. If you want to find out whether your function is concave up or concave down, you can find the derivative and see if the derivative is increasing or decreasing. And that will decide whether my function is concave up. And the opposite of that is true as well. If my function concave down, the slope of the tangent line is going to decrease as x increase. So my tangent line, it used to slant it up, it used to be very in the positive, but then it becomes less positive, it becomes negative, and it becomes very negative. So if my function is concave down, that would imply that the derivative is decreasing. show up. So that's the fourth item in my table. Now then, there is one more thing I can say. What does it mean for a function to be increasing? I just said that a function is increasing when the derivative is positive. So that actually kind of means if my derivative is increasing, that would imply that so I'm gonna use what I said here. If my function is increasing, the derivative is gonna be positive. So if my derivative is increasing, then the derivative of that need to be positive. But the derivative of this guy is the second derivative. So if my function concave up, the derivative is gonna be increasing. But because the derivative is increasing when I take derivative again, I'm gonna get the second derivative. And this second derivative has to be positive. So I get this extra column in my table there. So that means when the function is concave up, the derivative is going to be increasing and the second derivative is going to be positive. So these three guys are the same thing. And the same hold in the other case as well. If my function is decreasing, then my second derivative is going to be negative.